first of all, on this particular problem, I will normally say, what is the first step? And yes, I know for now, by now you're going to say, oh, you have to plug it in. Yes, but before I plug it in just this time, I will rearrange the function. Yes, plugging in is the first step, but I will rearrange the function first. And how do I do that? Can anyone tell us what this represents? Negative 2 plus x to negative 1. See why I picked this one?
1 over negative 2 plus.
Thank you, thank you, thank you. And 1 over 2. This is the key. Great job, thank you. So now I will definitely plug it in. So what do I get? And what is your hope? If it's not 15 or 10 or 20, if it's not a number, what is your hope that you will get here?
Does not exist. 0 over 0.
I hope for 0 over 0. Because 0 over 0, if it's not a number, if it's not 15, then I'm done. If it's 15, I'll write 15, I'll move on to the next problem. But if it's not that simple, I hope for 0 over 0. Why? Because 0 over 0 has hope. Yep. What about 5 over 0? Do you want 5 over 0?
No.
No, because that one will definitely have no hope. It's either infinity, negative infinity, or DNE. This is the only one. I prefer something like that. 15, 1500, negative 3, whatever. But if it's not that, my next hope is this. Okay, so what do we have?
The top is 0, the bottom is 0.
Excellent. So it's this situation in which I really hope that the limit exists. Perfect. What will be our next step?
Checking for when it approaches 0 from the left.
Very good point. No. We do that only in this situation. Very good point. Very good. Thank you. You remembered something, you paid attention. So let's go back for a second. I want to make sure that this is super clear. This was 4 over 0. Furthermore, the limit was determined when x approaches 2 from either side. Both conditions have to be fulfilled for us to look at both limits left and right. The answer has to be whatever over 0, not 0 over 0, and the limit has to be calculated when x approaches a number from either side. If both conditions are fulfilled, I have to find both limits before I draw this conclusion. Good point. But now, this is not the case. Why? Because I have 0 over 0. So then there must be something else I need to do next. Okay, here's your hint.
Combine fractions in the numerator.
Find the least common denominator. Great job. What is it?
Would it be negative 1 plus h? No.
Negative 2 h.
Okay, so let's talk about it. If I I have 1/2 plus 1/3, is the least common denominator 2 plus 3? Is it 2 minus 3?
Multiply.
Ah. 2 times what is 6?
3,
Excellent. 3 times what is 6?
2,
Excellent. 3 times 1 is
3,
plus 2 times 1 is
3. 3. 2.
good.
2.
That's okay. So the answer is 5/6. We cannot apply any other technique. This is it. So then, what is the least common denominator?
2 parentheses negative 2 plus h.
I'm going to correct it and write it as h minus 2. Excellent. It must be the product of the two. We are not adding, subtracting, doing anything else with the denominators, but product. Excellent. Great job. So please remember, this is the same technique. I know it looks differently because of the variables, but it's the same thing. Good. So then what does this need? It had h minus 2. What do I need to multiply it by? Great job. This one has 2. What do I need to multiply the top by?
H minus 2.
Great job. So 2 times 1 is 2, plus 1 times h minus 2. Good. Next step. The denominator can be written as h over 1. These two go away. So then the numerator is h over 2 times h minus 2. So then limit, h approaches 0, h over 2 times h minus 2, multiplied by 1 over h. H divided by h divided by h. So therefore the limit is, and now you can plug it in again. And what do we get?
0.
Not possible.
Like 4.
So the numerator goes to,
1.
the denominator goes to,
Negative 4.
very good. So the limit is negative 1 over 4. There was hope, and it materialized. Negative 1 over 4. Now let's go back to this function for a moment. If I cover this up, and I ask you, what do you think this is? What will you say?
Difference quotient.
Yay! Who said it?
Me, Andrew.
Thank you. Great job. So then two things have to happen. We talked about the difference quotient. We used it an hour almost. Two things have to happen. All terms in the numerator that do not have h must go away, and they do. And they did. What is the second thing that has to happen? The h in the denominator must cancel out. And it did. And that is the final answer. Any questions? I want to look at a radical one and one with absolute value. So I found the radical one right here. 27. Any questions on this, please? I mean, we can spend a month just on limits, honestly. There is no end to this. Okay, so 27, same thing in 2.3, and we have limit as t approaches 0, the square root of 1 plus t minus the square root of 1 minus t over t. Okay, what do we do now? What is the first step? I cannot rearrange this function, so
Plug in 0.
excellent. And what do we get? And what do we hope for? We hope for 5. That's my hope, 5. But it's not going to happen. So the next in line would be, I hope for 0 over 0. So then, which it is indeed. Perfect. So what do you think from your past experience with math we are going to do here? Any suggestion?
Multiply by a conjugate.
Very good. Rationalize. In this case, we are rationalizing the numerator, of course. So I'm going to change this because I'm lazy into multiplication instead of writing it one more time. And can anyone give us the conjugate?
Root 1 plus t plus root 1 minus t.
And it has to be the same top and bottom. Why? Because I can only multiply by 1. Not by 1 like this, but 1 like this. And this is 1. If I omit to write the denominator, I'm changing the problem. So can anyone give us the numerator? I will write the denominator.
Would the numerator be 1 plus t plus 1 minus t?
Careful.
In parentheses, each one of those?
No. I'm looking for something we wrote on the first day of classes, which I didn't save for your class, but I saved for another class, so I'm stealing it from another class. If I can pull it out of this today, because you never know. Ah, look at that. Okay, a plus b times a minus b equals
A squared minus b squared.
good. So now let's go back. What do I write? So when I multiply these two, I get 1 plus t. I cannot square one more time. So when I square this, I get 1 plus t.
T plus 1 minus t.
What do I write here?
Would it be 2 times the square root of, no, it's like,
So this is my a minus b, and this is my a plus b. We know how to square a, we know how to square b, and we have to put minus in between.
Parentheses 1 plus t plus 1 minus t.
So what is the symbol that I have to write?
plus or minus?
Okay. Let's go back. A plus b times a minus b equals a squared minus b squared.
Minus.
Yes, very good. Minus
uh, 1 plus t.
I cannot change anything that is inside.
I
But
One minus t.
when I square the square root, I cannot touch the inside in any way.
I'm sorry, I meant 1 minus t.
Very good. Excellent. Well done. So let's move on then. So this is limit t approaches 0. 1 plus t minus 1 plus t over t, the square root of 1 plus t plus the square root of 1 minus t equals. Okay. So then we simplify. What happens next? What do we do next then?
Also the t's from top and bottom, just one in each.
I cannot simplify terms. Careful, I cannot simplify terms.
Add them together and it's 2t.
Yes. First of all, I have to write 2t. Very good. Well done. And t, the square root of 1 plus t plus the square root of 1 minus t. Absolutely true. I have to simplify. And what is the final form? Simplify, done. The limit. Oh, one thing I want to make sure that you understand. If you drop the limit operator before the final step, I can never give full credit for what you're doing. So if you write this, limit this, and then you write negative 1/4, you will not get credit for it. Notice that the limit operator does not drop till the moment I am ready to calculate the limit. I'm not ready to calculate the limit here, 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 here. I'm only ready to calculate the limit here. That's when the limit operator drops or disappears because it was applied. It's like saying the square root of 9 is the square root of 3. No. I already applied the operator on 9 and I get 3. That's when the square root operator disappears. So please make sure that your limit operator is present all the time till the last step. Very important. Makes no sense. If I drop the limit operator here, it makes no sense. This is garbage.
Do we need to put the equal sign in front of the limit?
Yeah. If you don't want to put it here, I put it here just to show you that I'm not done. Because if you don't see this and you don't see that, you'll say, oh, it's done. It's just a habit. If you don't want to put it here, it's fine, but you have to put it at least here. So what is the limit? The top goes to
T.
very good, awesome. The bottom goes to
The square root of 1 plus t plus the square root of 1 minus t.
no. I dropped the limit operator.
Oh. So 2.
Excellent. So then the limit is 1. Awesome. Well done. Well done. Okay. We only have 7 minutes left. Let's start working on something because I will not be able to show a, I had in mind an absolute value function, and also this section is not finished. You cannot work on 2.3. You can start, but I have a theorem that I have not gotten to. It's called the squeeze theorem. So I did not get to that yet. So
I have a quick question about the limit of the function quiz on Canvas.
yes.
I put negative infinity, and I'm pretty sure I marked it wrong.
Because I think I wrote the answer as negative INF.
Oh, okay.
Yeah, I didn't insert the symbol, I think, yeah. Remember, if you enter the correct answer in a different form, you always get the point.
Me.
Okay, so do you go back and review those?
Always. Yes, I always do. I always add up the points, etc., etc. Yep. So let's start. We have 5 minutes left. So let's start, and I will add a couple of questions for 2.2, but let's go and work on 2.3. How do you feel so far about limits? Were you able to keep up? I mean, I've been doing